Hey everybody, it's Miss Hill, and I am back today to help you create a mid-module review cheat sheet. So your job this week in math is going to be to complete your mid-module quiz. This score will be counted based on how well you do, so it is not just a score for completion. So today's cheat sheet is really, really important that you get copied down into your spiral or note page, wherever you're recording information, because we're going to let you use this cheat sheet as you take your mid-module quiz. All right, we're going to cover two main topics today onto our cheat sheet that we've covered in this module. The first topic that we're going to go over today is a review of what it means for something to be a rational number. We're going to look at some examples. We're going to talk a definition, and we're going to get that all on this single sheet to use as you're doing your quiz. The second thing that we're going to talk about today is a really quick review of all of those exponent rules. All right, let's get started. So whenever I am trying to understand something new or understand the definition of something, it's important for me to know what the opposite is of that number or of that topic. So let's make a really quick T-chart. And I'm going to title one of those columns rational numbers. And I'm going to title the other column irrational numbers. So rational numbers. Rational numbers are numbers that end. They might repeat indefinitely. I think I just spelled that word wrong, but we're just going to leave it and we're going to move forward. So they are numbers that end. They are numbers that might repeat, and they might do that indefinitely, like infinitely, right? But they're repeating. There's a pattern going on. And most importantly, what I know to be true is that I can predict these numbers. So I know what's next. I can predict what's next. The opposite is true of irrational numbers. So irrational numbers never end. They go on and on forever. They do not repeat. I repeat, they do not repeat. And I cannot predict what is going to happen next. Just like rational people, if you have somebody in your life who is very predictable, you know what they're going to do. They're pretty even-keeled. They respond the same way all the time. That's somebody we consider rational. An irrational person would be somebody whose behavior is all over the place. You don't know what they're going to do next. We would call them irrational. So the same thing holds true for numbers. Let's talk about some examples of what that would be. So I'm going to extend my T-chart just a little bit so that I've got a little space here to put some examples of both of these types of numbers. So let me start with rational numbers. A rational number that ends would be like the number 2, right? I know what it means. It's ended. It's not going on forever. Game over. Another example might be 3.3333 with that fun repeater bar up there, right? What's it going to do next? 3. And after that, 3. And after that, 3, right? That's just going to keep going. I know what it's going to do next. Even though it never ends, I know it's happening next. That might even be true for an example like 4.1414, and that 14 is repeating, right? So as long as there's a pattern to that repetition, it is considered rational. I know what's coming next. I'm going to get a 1, and then a 4, and a 1, and a 4. So those would be considered rational numbers. I could even have a square root, like the square root of 25 would be rational because what's that answer? 5, right? Square root of 25 is 5. So the answer to that square root is a number that ends. Okay, or if it was a number that repeated indefinitely, that would be okay too. Irrational is going to be opposite types of examples. So you guys have seen pi. That's an example of an irrational number. That goes on and on and on forever. There isn't a pattern to the numbers that are coming next, right? We've just memorized a short section, but it goes on and on forever. So pi would be an example. The square root of 2 is considered irrational because that's going to go on and on and on forever, and it doesn't have a pattern to it. So any number that continues on and it's changing its number every single time and I cannot predict it, that would be considered irrational. So skill set number 1 you need to have ready in your pocket for this quiz is being able to identify rational numbers. So if I were to give you a list of numbers, could you tell me, does it end, or if it doesn't end, if it repeats, does it repeat indefinitely that same number or set of numbers over and over and over again? Okay, so that's step 1, rational numbers, being able to pick a rational number out of a set of numbers. Skill set number 2 is using those exponent rules. So really fast cheat sheet on exponent rules. Let's title this section Exponent Rules. And I'm actually going to go the T-chart route, and I'm going to do rules on one side, and I'm going to do exponent examples on the other side. All right, so the first rule that you had, I'm just going to write mult, right? That was your multiplication rule. So basically, if I have the base of x raised to the a power, and I'm multiplying that by the same base of x to the b power, all I'm going to do is I'm going to add those exponents up, a plus b. An example there might be, let's say 4 to the 5th power times 4 to the, I'm going to get wild here and go -2 power. So I'm going to keep my 4, right? The base does not change. And I'm going to add my exponents. I'm going to do 5 plus a -2. So that's going to give me 4 to the 3rd power. The second rule that we worked on was the division rule. So I'm going to write div for division. That would be if I have x to the a, I'm going to use the same example, divided by x to the b. I am going to subtract, so a minus b. Let's use this similar example. Let's say I've got 4 to the 5th divided by 4 to the -2. What that means is I'm going to subtract my exponents. 5 minus a -2. Ooh, that's not simple. I'm going to keep my base. If I'm standing on 5 on a number line, normally if I subtracted 2, I'd move left 2. However, the subtraction and the negative are going to reverse direction, so I'm really going to move to the right 2. So what do I end up with? 4 to the 7th power. If you remember KFC, right? Keep, flip, change. I would keep the 5, flip to addition, change the sign of the second number. Hopefully that's jogging some stuff in that brain. Okay, the next rule was power to power. And what that looked like was if I had a base of x, let's say, and it was raised to the a power, and then that whole thing had parentheses around it and raised up again to another exponent. Here I keep my base and I multiply those exponents. So for example, let's say that I had 7 to the 10th power, and that whole thing was being raised up to another third power. I keep my base. I multiply these exponents, 7 to the 30th power. The next rule that we talked about was your 0 power, and that meant any base to the 0 power was going to be equal to 1. So let's say I've got that base of 7 again, and it's to the 0 power. That means that value is 1. So no matter what I multiply by, I'm really only multiplying by 1. And I'll do an example of that in just a sec. Your last rule was the negative exponent rule. And what we talked about with the negative exponent rule was if I get an answer, a base, with a negative exponent, so negative b, let's say, in order to write that as a positive exponent, in order to convert that to positivity, I'm going to keep the base and I'm going to keep that exponent, but I'm going to find the reciprocal. So I'm actually going to move it into the denominator, and by doing so, my exponent becomes positive. So let's say that I had the example of, we'll go back up here and take this 4 to the negative 2. If I get this as my answer, I need to convert that into a positive exponent by finding the reciprocal, in this case, flipping it into the denominator, keeping the base, keeping the exponent, just changing the sign of the exponent. Okay, that's our cheat sheet. You've got info about rational and irrational. You've got exponent rules. I'm going to run through some examples that you are going to see on this quiz. I'm just going to change some numbers, but I want you to see the exact type of problems that you are going to come in contact with. So we are going to call this quiz examples. No surprises. Ms. Hill hates a surprise. So quiz examples. Number 1, you might see a problem on this quiz that looks like this. I could have a base of 2, and the 2 is raised up to a 4, and then they go, well, that whole thing's raised up to x. Yikes, never seen that before. And they're already telling me that it's equal to 2 to the 8th power. Crazy one-step equation solving, right? So what I'm asking myself is, what number goes in the x spot? That's the variable. So what number times 4? Because I know this is power to power, I'm going to multiply these two numbers in order to get this number. So what I'm asking myself is, what number times 4 is going to give me 8? Well, just really fast, if I divide by 4, right, x is going to be equal to 2. So I'm just asking myself what number would fit into that spot for that variable to make that math sentence true. Another type of example that you are going to see on this practice quiz, or sorry, this actual quiz, is, let's say you have a base of 4, and it is raised up to the 5th power. And then that whole thing is cubed, raised to the 3rd power. And we're multiplying it by the same base of 4 to the 0 power. Well, what does this whole thing even equal right here? That equals 1. So I'm multiplying 4 to the 5th raised up to the 3rd. I'm multiplying that by 1. So that's not going to change anything. So really all that means is they want me to solve this, right? Because I just would be multiplying by 1 in the end. Again, this is power to power. So I'm going to multiply those exponents, keep my base, and do 5 times 3, which will give me 4 to the 15th power. All right, we're going to do 2 more. So your next type of problem you're going to see is going to be a problem that ends with a negative answer. So let's do this example. 5 to the 6th power times 5 to the negative 8 power. So multiplying like bases, nothing wild here, right? But when I multiply like bases, I add my exponents. So if I keep my base of 5, I'm going to add 6 plus a negative 8. If I add 6 plus a negative 8, that's going to give me 5 to the negative 2. I can't leave my answer like that. I need to convert that to a positive exponent. So to do so, I'm simply going to flip it into the denominator, make that exponent positive. Okay. The last example that I want to give you that you could use as you're doing this quiz is if it's written with all variables. What on earth do you do? So let's say that they give you r to the m power divided by r to the n power. And it's written like that. You don't know what on earth you're supposed to do. It's just showing you what the rule is. So I'm going to keep my base. Here, I am dividing like bases, so that means I'm going to subtract my exponents. So my answer is that, r to the m minus n. Not much else I can do. I really hope that these examples and this cheat sheet are helpful for you. Use them as you complete your mid-module quiz. Remember, the entire point of this mid-module quiz is just to check in, get some data, and figure out how we need to support you. So good luck. Have a great week.